Okay, so today we're going to work on partial fraction decomposition, and partial fraction decomposition is basically an algebraic technique that we can use to deal with rational expressions, which is a polynomial divided by a polynomial. So we have a couple cases. We're going to focus on case one, case two, and case three, and I'll write those kind of down as we go. This problem, however, is not case one. This is not case two, or this is not case three. If you notice, the numerator power is larger than the denominator power, okay? Or the degree of the numerator is larger than the degree of the denominator. So I told you guys that the best way to deal with this is to do long division. So this still holds for partial fraction decomposition. When you're dealing with rational expressions, you probably shouldn't do partial fractions in this case. You should probably just do long division. So I'm just going to do long division, x squared plus 1. Okay. And then what I'm going to do is I'm just going to ask myself, what does x squared need to become an x cubed? It needs a times x. So this will become x cubed plus x. And I draw my division. But the moment you draw your division, you subtract, you change the symbols. So this will cancel and become 0. This will become negative 4x plus 2. Now, because the degree is larger than this degree of 1, we're pretty much done. So we have now found that when we do the long division of this, this is going to be x plus negative 4x plus 2 divided by x squared plus 1. Okay, so this will now be what we integrate. So now I'm going to integrate x plus negative 4x plus 2 over x squared plus 1 dx. Okay, hold on one second. Okay, so now we have to integrate all of these pieces. So this one will be piece by piece, term by term. So this will be x dx, the integral. This one will be plus, you know what, I think I'm going to split this guy. I'm going to split them like this divided by this and this divided by this, because I don't see the u sub quite working how I want. So I'm going to do negative 4x integral over x squared plus 1 dx plus 2 over x squared plus 1 dx integral. So now when I see these three problems, I'm going to have x squared over 2 minus, now this, just so you guys know, this is going to be a little u sub. You know what, I'm going to write it out just so I don't cause any confusion. This will be minus 4 integral x over x squared plus 1. But hopefully you guys can see that the power of the numerator is only different than the power of the denominator by 1. So that probably means u sub is going to work. And then this one will be plus 2 integral of 1 over x squared plus 1 dx. Now, this should look awfully familiar to you. This should look exactly like the arctan that you're used to seeing. So we kind of already know how to do that one. This one is just going to require a little u sub. So u is equal to x squared plus 1. Du is equal to 2x dx. Divide both sides by 2. So we have x dx is worth d over 2. So I think we're good. We can go from here. So this will become x squared over 2 minus 4 integral of 1/2 times 1 over, well, you know what, let's write it like this. So this will be 1 over u times 1/2 du plus 2 tan inverse of x plus c. Now we still have to integrate this little u one right here. So this will be x squared over 2 minus 2 ln of the absolute value of u plus 2 tan inverse. And you guys could probably combine a few steps here. You know, I probably should have been able to do this in my head from the beginning, but I'm just trying to show all my work. So this will become minus 2 natural log x squared plus 1 plus 2 tan inverse x plus c. Okay, so that's how we would do that problem. And again, that didn't even require partial fraction decomposition. That simply required us to do long division. So this would be our answer that is acceptable on the exam. Okay, in reality, you may not even need to write this. I would see how the homework is. You may not need the absolute values because x squared is always a positive. And then when you add 1 to a positive, you're always going to get a positive. So it's a little redundant. But we'll just leave it for now. Okay, so now let's look at case 1. So case 1 for partial fraction decomposition. Okay, so case 1 involves, so case 1 is non-repeating linear factors, okay, in the denominator. Okay, so this is kind of how you identify it. So you might get something nice and easy like this one. Let's say we have the integral of 3 over x minus 1 times x plus 2 dx. So what you do in this case, is your goal is to kind of take a step back to pre-calc, and you want to rewrite 3 over x minus 1 as a fraction, like where it came from, like, you know, when they had separate denominators. So that means I'm going to rewrite this as a over x minus 1 plus b over x plus 2. So this should have been a technique you learned in pre-calc. If you didn't, I'm kind of reviewing it a little bit here. So again, we're not integrating right now. We're just trying to find a new way to rewrite this. Kind of the goal is that you guys see here, I don't really see how to integrate this problem. Splitting it won't work. U sub's not going to work. It seems like you can't integrate this. So we're going to use partial fraction decomposition to help us with this rational function or rational expression. So what you do is you always take a look at the factors of the denominator and you write them right here, okay, for non-repeating. This is how you do it. Case 2 will be for repeating linear factors, and then I'll show you how to do that as well. So now we have to solve for a and b. So we're going to do a little scratch work. We're going to say let x equal a very nice x. What x could we use? Oops, hold on, not yet. I forgot. We got to do one thing. We got to clear the denominator on one of the sides. So what I'm going to do is I'm going to multiply by the LCD. So when I do this, this will cancel with this, right? So we're just left with the plain old 3. But now I have to do it to this whole thing, x minus 1, x plus 2, and then we distribute this whole thing to each of them. So whatever we cancel doesn't actually cancel for both of them. It only cancels for one. So when we cancel, or when we do x minus 1, x plus 2 times this guy, we're going to be left with a times x plus 2 because the x minus 1's cancel. This one will be left with b times x minus 1 because the x plus 2's cancel. So now what you do is you choose a good x, an x that is really going to help you, okay? So what x's are going to help you are the ones that eliminate a large chunk of the problem, basically meaning you turn things into 0. You don't always have to do this, but this is kind of the best way to do it, if you can. So you let x equals -2, okay? And that means we'll have 3 equals a times 0 plus b times -3. So then 3 is equal to -3b. Divide by -3, divide by -3. So we have -1 is equal to b. So that's what our b is. So now I'm going to come over here and I'm going to let x equal +1 because that'll make this guy 0, right? So then when I do this, I'm going to have 3 equals 3a plus 0 b's. So then now 1 is equal to a, okay? So now the goal of this is you know your a and you know your b. So now I can rewrite this. This will now become the integral of a over x minus 1. So a 1 over x minus 1 dx plus the integral. I'm going to integrate piece by piece. The integral of b, but b is -1 over x plus 2 dx, right? So now this will be the natural log of the absolute value of x minus 1 minus the natural log of x plus 2 plus c. Okay. Now, I think in your homework, they want you to clean this up. So this is how you should do it on the exam. This will become x minus 1 over x plus 2 plus c. Remember the old property of logs that if you subtract two logs that have the same base, then you can just divide their arguments. So I think this is how most of the homework will be. Okay, so just be careful of this. So that's like the base, like super nice, easy one. You know, they don't really get much better than that. I think I'm going to focus more on case 2 because this is the one more people have trouble with, and case 3. So let's look at case 2 now. So case 2 has repeated or repeating linear factors. So again, everything's still linear in the denominator, but now they're repeated. So let's look at an example of this one. That one looks too hard. Okay, let me find one that's more realistic. Yeah, this one looks good. So this one is 4 over x plus 1 times x plus 2 squared dx. So now notice, this is x plus 2. That's a linear factor. This is x plus 1. That's a linear factor. But this linear factor is squared. So that's what they mean by repeating linear factors, okay, or repeated linear factors. It's really x plus 2 times another x plus 2. So it repeated itself. So I'm going to come over here. I'm going to do my PFD. I'm going to decompose this because I don't see how to factor this, or I don't see how to integrate this. Remember, in general, when you guys see a rational expression or something, a polynomial divided by a polynomial, which is a rational function, a rational expression, it normally means that you're going to have to do partial fraction decomposition. Not all the time. You know, sometimes it's a U sub. Sometimes U sub will work on this as well. Sometimes it'll be long division. But you'll start recognizing the more of these you do in the homework, your partial fraction decomposition is kind of your go-to move when you're dealing with these. So I'm going to take 4 over, and again, we're not doing calculus right now. We're just doing a little algebra rewrite. 4 over, and then here's how you do repeating linear factors, is you do a over x plus 1, same as before, b over x plus 2, same as before, but now you have to account for the repeated factor. So you do another one, c over x plus 2 quantity squared. Now, what if there were x plus 2 cubed? Then you would do another one plus d over x plus 2 cubed. You have to account for every single power. So the first power, the second power, the third, however many there are, you got to keep counting up, and you have to keep rewriting a constant above it. So now the LCD, we see that the LCD is going to be x plus 1 times x plus 2 quantity squared. So we're going to multiply that to both sides, x plus 1 times x plus 2 quantity squared. And once again, this will cancel that, and those will become 1s. So we're happy about that. And now we have to distribute this to each one of these, okay? So we have 4 equals a. Now the x plus 1s cancel, and I'm left with x plus 2 quantity squared plus b. One of the x plus 2s cancel, but one of them stays. So I'm left with 1x plus 2 plus c times x plus 1, right? Because, for example, this both cancels with both of these, and that leaves us with an x plus 1. Then when I do it with this one, this cancels with one of these, and I'm still left with these two. And then this cancels with this one, and I'm left with x plus 1 squared. And that's where I'm getting these factors, by the way. Okay. Let me just clean that up. Okay, so we're here. So now pause the video and kind of practice doing your partial fraction decomposition now. We have to solve for A, B, and C. What do you think are good x's to choose? So pause the video and try to solve for A, B, and C. And then when you come back, I'll go over it with you. Okay, so hopefully you guys you said let x equal -2. That seems like a really good x to use. So this would be 4 equals 0 a's, right? Or I'm sorry, I'll just say 0 a times 0 plus b times 0 plus, now -2 plus 1 over here would be, what's that, -1 times c, so this would be minus c. Okay, so now we're going to divide both sides by -1 and -1. Remember, these are all gone. These are just zeros because a times 0 or b times 0. So now we have that c is worth -4. Okay, so we got c is worth -4. That's great. Now let's do x equals what? What's another good x to choose? Well, -1. So when I choose x to be -1, I get 4 equals. Now, if I plug -1 into all of these locations, I got to see what happens. So this one, -1 plus 2 will be 1. So this will be a. So 1 times a is just a. This will then become 0 right here. This will become 0. And then this will become 0. So I have a equals 4, and I'm done. Well, that was an easy one. Okay, so a equals 4. That's nice and clean. Okay, now we have to find b somehow, but we've already used our two best x's. The two best x's we could use were -1 and -2 because they wiped everything out. But they almost did too good of a job because they didn't leave anything left to find for b. So now you can pick any x you want. What's the easiest x you think to work with? I'm going to say the easiest x for me to work with is x equals 0. So I'm just going to go, 4 equals 0 plus 2 is 2. 2 squared is 4a. Plus, now 0 plus 1 is 1, plus 2 is 0 plus 2 is 2. So 2 times 1 is 2, so 2b. And then this would be plus c. So that's all I did. I just plugged 0 in for all my x's, right? And this is what I ended up with, okay? Now we have to solve for b. But I do actually know a, right? Because a is worth 4. And I do actually know c because c is worth -4. So let's plug that in. Did I make a mistake anywhere? So we have 4 equals, now a, this would be 16 plus 2b minus 4. So this would be 4 equals 12 plus 2b minus 12 minus 12, right? So then this will be -8 is equal to 2b, divide by 2, divide by 2. So -4 is equal to b. So we now have our b. So our b is -4, our a is a, and our c is -4. So now we can rewrite our integral. So this is going to be the integral of, now we go back up here, this, we're going to integrate this now, right? So this will be a over x plus 1. So a was worth 4, so 4 over x plus 1 dx. Oops, I'll write it as one big one first. Plus, actually it's minus, right? Minus b, which is 4 over x plus 2 minus c, which would, or plus a negative c, which is not negative c, but you know what I mean. C is -4, so this will be 4 over x plus 2 quantity squared. Okay, and then dx. So this is our new problem. So this problem came from this guy. Oops, I suppose I should have wrote it over there. So this is the same as this. There's no difference. We just wrote it slightly differently, okay? So now this is going to become 4 natural log of the absolute value of x plus 1 minus 4 natural log of the absolute value of x plus 2. And remember, these are actually little baby u subs, but these I will actually allow you guys to do in your head because the u is x plus 2 and du is just dx. So these all wipe out clean. Minus, you know what, I should write it like this. I shouldn't be lazy. The integral 4 integral 1 over x plus 1 dx minus 4 integral 1 over x plus 2 dx minus 4 integral 1 over x plus 2 quantity squared dx. So this one will be 4 ln of absolute value x plus 1. So these are the easy ones. A natural log of x plus 2 absolute value. Now this one is actually a little u sub. I got to do u equals x plus 2, du is equal to dx, and then this will become minus 4 integral of u to the -2 du, right? So now plus c. So now let's do this. 4 natural log x plus 1 minus 4 natural log absolute value x plus 2. Now this will become plus 4. Now it's u to the -2 plus 1, which becomes u to the -1 over -1. So that's how I got my plus. And this becomes u, but we know what u is. U is x plus 2. So I'm just going to say x plus 2 to the -1 plus c. Okay. So we actually do not end up with another natural log. This one does not require natural logs because it's a -2 power, not a -1 power. Okay. So I think your homework's going to ask you to factor this. So this will become 4 natural log of the absolute value of x plus 1 over x plus 2 plus 1 over x plus 2 plus c. That would be like the cleanest way that it could be written, but I absolutely would take this answer. This answer is acceptable to me, but to get it right in the homework, you may have to do the next step. On your exam, if you left this one, I would be fine with it. That's as clean as I need. I like it. So that's case 2. So let me see if I have another one for case 2 for you. I think this one is case 2 still. No, that's actually case 1. Oh no, that's long division actually. Okay, so let me give you this one to work on. So let's say that I give you another example of the integral of 2 over 3x plus 1. And they're not always factored like this for you guys. This is just how I did these few, but you know, sometimes you might find some that you have to factor yourself. You know, and that just makes it one little extra added step. Okay. You know, let me erase that 3x plus 1. Okay, so you guys should pause the video and see if you guys could now do this problem. Let me see, I didn't do one exactly like this, right? This is really close. This is just more practice. So go ahead and pause the video and see if you guys can do this one without my help. Okay, so you guys should be back. And now you know that this, you're gonna be doing 2 over 3x plus 1. You're gonna create a partial fraction decomposition for this. And that's gonna equal a over 3x plus 1 plus b over x plus 1 plus c over x plus 1 quantity squared. Okay, so now we have to multiply everything by the LCD, 3x plus 1, x plus 1 quantity squared. And then we come over here, 3x plus 1 times x plus 1 quantity squared. This will cancel with this, just like it always does. This should be something you're kind of getting comfortable seeing. This will become a times x plus 1 quantity squared plus b times x plus 1 and a 3x plus 1 plus c times 3x plus 1. So everything cancels. Okay, hold on one second. Okay, yeah, sorry, it was getting really hot in here, guys. I gotta turn on the fan. Okay, so now you guys gotta choose your really good x's. So a good x, maybe I'll do it in blue so it looks a little bit separate. A good x is -1, right? So that means that this is 2 equals 0 plus 0 plus, now -1 times 3, so I'm over here now. -1 times 3 is going to be -3 plus 1 would be -2, so this will be -2c. Divide both sides by -2, so we get -1 is equal to c. So that's our c. Now another good x would be what? -1/3. All I did was I solved that, set it equal to 0, and solved it in my head, so we get -1/3. So now I'm going to go 2 equals a times, I'm going to write this out because fractions aren't everybody's friend, squared plus 0 and then plus 0, right? Because -1/3 is going to cancel both of those 3x plus 1s and become 0. So then we just have to do 2 is equal to a times 2/3 squared. So 2 is equal to 4/9 a. So then we multiply both sides by 9 over 4. Cancel, 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 cancel. But then I got to put a, you know what, I'm going to do it like this. 9 over 4 here, 9 over 4 here. Cancel, 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 cancel. Everything becomes 1. This will cancel. This is 2 over 1. That becomes a 2. So we get 9 halves. Oops. So we get A equals, I think it's 9 halves, right? So we have A equals to 9 halves. So that's another value we now have. And then let me come over here. And once again, it's almost like our x's work too good. So now we just have to pick an x that we're comfortable working with. I think 0 is going to be the easiest one to work with. Sometimes it might be 7. Sometimes it might be 2. But in this case, I think 0 is going to help me the best. So I'm going to have 2 equals A. So 0 plus 1 is 1. Squared is still 1. Plus B times, what is that? 1 times 1. So that'll be B. And then C will be plus C. Now remember, we know A and we know C. So I'm going to say 2 is equal to 9 halves plus B minus 1. So then 9 halves minus 1 is actually 7 halves. So I'm just going to do all this on my calculator. I'm going to do 9 divided by 2 minus 1 is 7 halves. And then I'm going to do 2 divided by 7 divided by 2. And that is 4/7. So I have B is equal to 4 over 7. Okay, so we now know our B. So hopefully you guys got this. So now pause the video again and try to plug these in and integrate without me just telling you how to do it. Try to do it without my help. And then, obviously unpause it so we can kind of go over it and see if you got it right. Okay, so now we're going to come down here with this. Hopefully you did this. So we have the integral of, now I'm going to integrate piece by piece because I already know you guys, you've done enough of these. This is like your second or third one. You know that we're going to integrate this, we're going to integrate this, and we're going to integrate this. So I'm just going to write that out. I'm going to skip a step and write that all out. So now we're going to say that A over 3x plus 1, but we know A is 9 halves. So I'm going to put the 9 halves out here. 1 over 3x plus 1 dx. And this is just kind of makes our lives a little bit faster. We know B is plus 4/7 integral 1 over x plus 1 dx minus integral, that's C, right? C is negative 1 over x plus 1 quantity squared dx. So it's kind of similar to what we did in the previous problem. So now this will require a little bit of a use of. U equals 3x plus 1, du is equal to 3 dx, divide both sides by 3. So now we're going to have 9 halves times 1/3 ln of u, but we know u is 3x plus 1, plus 4 over 7 ln of absolute value of x plus 1, so the natural log of absolute value x plus 1, minus, now this is another u sub, u equals x plus 1, du equals dx, right? So we end up with negative integral of u to the negative 2 du, right? So when we integrate that, it's just like before, it's going to become plus u to the negative 1 plus c, okay? Because u to the negative 1 over 1 changes that minus sign into a plus sign. So now when we rewrite this, this can cancel with this, and this becomes 3 halves. So 3 halves, natural log of 3x plus 1 plus 4/7 natural log of x plus 1 plus 1 over x plus 1 plus c. And this would be an answer. Now in the homework, they might be more particular. So then you have to do the ln of the absolute value of 3x plus 1 to the 3/2 power plus ln of absolute value of x plus 1 to the 4/7 power. Remember, all I'm doing is I'm putting the power, that's a property of logs, that when you want to combine logarithms, there has to be a 1 in front. So I have to move those back up to the exponent, plus 1 over x plus 1 plus c. So then the book may ask you to then do this. Okay, so that's how they might ask you to clean it up. I would take this answer up here though. That answer is totally acceptable to me. I actually prefer it, but this answer is a little bit cleaner looking. I can see the point why the book wants you to clean it up. Okay, so let's look at case 3 now. So case 3 has to do with non-repeating non-repeating irreducible quadratics. Oh, I spelled it wrong. Irreducible. So that means that you're going to have a quadratic factor that cannot be simplified. So when you say irreducible, that just means it cannot be factored by the normal means, okay? So like x squared plus 2. X squared plus 2 is a quadratic and it can't be factored, okay? It's in irreducible form. So that's what it means by non-repeating irreducible quadratics. So the best way I can show you is let's look at one. So let's look at this guy. So we have the integral of 2x squared minus x plus 4 all over x cubed plus 4x dx. So the first thing is you notice it's not in factored form, so sometimes you have to do that yourself. So this will become 2x squared minus x plus 4 all over x times x squared plus 4. Okay, now the x squared plus 4 is a quadratic and it cannot be factored into linear form, you know, unless you use square roots or whatever like that, and imaginary numbers probably, or definitely. So as far as we're concerned, this is an irreducible quadratic, okay? So here's the thing, we're gonna rewrite it like this. So we're gonna rewrite it as 2x squared minus x plus 4 all over x times x squared plus 4. We're going to leave a little space because we now have kind of learned that we're going to have to multiply by the LCD. And then we're going to go over here and do a over x. So just like before, this is a single linear factor. So I'm doing the normal constant over the linear factor. Plus bx plus c. So they have to be within 1 degree of each other. So this is a first power, and it's to account for the fact that the denominator this time is an irreducible quadratic, okay? And it's not like in the previous case where you had x plus 2 squared or x plus 1 squared. That was a linear factor that was repeated. This is not a repeated factor. This is just x plus 4, and it can't be reduced. It's an irreducible polynomial or an irreducible quadratic. So we have bx plus c. So this little added feature is what makes case 3 a little bit harder, okay? So now we're going to multiply by the LCD, which we've been doing so far, x times x squared plus 4, right, over 1. And then we're going to do the whole thing over here as well, x times x squared plus 4 over 1. And let's see what happens. So once again, you guys should see that that cancels with that. And we're left with 2x squared minus x plus 4 equals, oops, yeah, I'm sorry. So then this will be a times, so I thought I messed up, x squared plus 4 plus bx plus c, put parentheses around that, times x, right? Because this cancels with this that time, okay? Let me see here. Okay, so now we have to choose a good x. So what is a good x? I would say a good x is, well, there's really nothing that can make this 0, right? If you guys notice, there's nothing that we can do to that to make it 0, because that is x squared plus 4. That will always be positive plus 4. So maybe we should focus in over here. Let's focus in over on this guy. What could make this 0? Well, we could use x equals 0. So that'll help us a little bit. So this will become 0, 2 times 0 minus 0 plus 4. So this will become 4 equals 4 4a, right? Because when I plug 0 in here, I just get 0 plus 4. So that'll be 4a plus 0. So then a is equal to 1, right? So no problem, nice and easy. Now we run into trouble because now there's really not another good x. So what I would do if I were you is I would pick an easy x, maybe not a good one, but something that's easy to calculate. So I'm going to say let x equal 1, just because I feel like I can calculate with 1 pretty easy. So this will become 2 minus 1 plus 4 equals 1 squared plus 4 is 5, so this will be 5a plus, now this will be b plus c, okay, because I plugged a 1 into here and I plugged a 1 into there. All right, so now I have 5a plus b plus c is equal to, what is that? 2 minus 1 is 1, so this will be 5 equals 5a plus b plus c. So that doesn't look so good. All right, so maybe I'll go again. Let me see here. How can I do this? Geez, I don't know. That's going to be a rough one, huh? I guess we got to pick another x. Let's pick, I guess, maybe 2. I wonder if -1 would be better. I'll just say x equals 2. I was just trying to think of another good one, but I'll just do x equals 2. So this will be 4 times 2 is 8 minus 2 plus 4 equals, well, that's 4 plus 4 is 8. So this is 8a plus, let's see, 2b times 2. So that would be 4b. And then 2c. So this will become 6 plus 4 is 10 is equal to 8a plus 4b plus 2c. Okay, so that looks kind of rough. All right, so maybe I can make my life a little bit easier. Let's kind of write all these out now. So I have a equals 1. I have 5a plus b plus c equals 5. And I have 8a plus 4b plus 2c is equal to 10. So these are 3 equations that I have. Do you guys remember anything that will help you deal with this situation? This looks an awful lot like a system of equations. I believe I could make it a little easier by plugging a in if I wanted. I could plug a equals 1 into here and here, but I just want to show you guys, let's build a matrix. So I'm going to build a matrix of 1, 0, 0, augmented matrix, by the way. So you guys should have learned this in pre-calc once again. So this is an augmented matrix. And then this becomes 5, 1, 1, 5. Hopefully I did all this right. 8, 4, 2, 10. Now what I'd like you guys to do is to log on to your calculators. Okay, so hopefully my calculator opens pretty soon. So let's go into our calculator. Okay. So I'm going to just plug this in real quick into my calculator so I can go back and look at it so I don't have to keep hopping back and forth between screens. Just give me 1 second. Okay, so I have this plugged in now. And let's see here. Yeah, so what I want you guys to do now is I want you guys to, so you have this written down and you need to take out your calculator and we're gonna RREF it. So we're gonna go and we're gonna use the RREF F function. Remember from pre-calc, this is how you can take a matrix and put it in reduced row echelon form. And what that does is it tells you what X is equal to, what Y is equal to, C is, or Z, or in our case, A, B, and C. So when we do this, I'm going to show you guys how I do it. And again, you should have learned this before, but if not, you can always look this up online. So let's clear this. Okay. Oops. So what I'm going to do is I'm going to go into second function matrix right here. See where that red button is? And I'm going to edit my matrix. So I'm going to go over to edit and I'm going to hit enter. This matrix is a 3-row by 4-column, by 4-column matrix. And now they want us to enter everything in. So I'm going to go 1, 0, 0, 1, I believe, right? Yep. Now I'm going to go 5, 1, 1, 5. Okay. Now I'm going to enter in 8, 4, 2, and then I think this was 10, right? Does that sound correct? Yeah, that was 10. Okay, so we've entered this into our matrix. Now we're going to get out of here. We're going to go second function quit. Now go back into matrices, and this time we're going to do math with our matrix. We're going to do math, and we're going to go all the way down to RREF. So there's REF. We want RREF, which is reduced row echelon form. And now it's asking you which matrix you want to reduce row echelon form on, perform it on. So we're going to go second matrix, and we're going to do it on matrix A, and hit enter again. So I get 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, negative 1. So let me do this on the other page now. So this page will now be 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, and then 1, 1, negative 1, right? So here's the thing. This is your A, this is your B, and this is your C, okay? So that means then that capital A equals 1, but we already knew that. Capital B is equal to 1, and C is equal to negative 1. So all that means is now when I want to rewrite this guy, I'm going to rewrite it, I'm going to rewrite it as the integral. And now we're going to do A, which is 1 over x dx plus integral of bx plus c, right? Bx plus c over x squared plus 4. Okay, so you guys see all I'm doing is I'm taking the integral of this now, x squared plus 4, and it said bx plus c. But we said that b was 1 and c, so 1x plus c, but c was negative 1. So we're going to say x minus 1. Okay, dx. So again, this is a harder style of problem because it requires a little bit of extra solving. There are other ways to do it. I could have shown you another way. Maybe I'll show that in the meeting if any of you want to see it, but I don't know if the other way is any better. But we can go over it in the meeting as well. But I'm starting to run out of time, so I got to finish up this video. I'm about to start one of my other classes. So we have 1 over x dx plus x minus 1 over x squared plus 4. Now this one, hopefully you guys recognize, is a u sub, right? Actually, no, it's not. I am wrong. It's not a u sub now that I look at it. So this one will just be the natural log of the absolute value of x, right? Now this one we're going to split as x over x squared plus 4. I thought it was a u sub, but then when I looked at it, how would I have accounted for the negative 1 up there? That would have been a problem. So I'm going to split it, and I'm going to do x over x squared plus 4 minus the integral of 1 over x squared plus 4 dx. I just took this negative and put it right here, okay? I just took that negative and it's right there, all right? So now this one is a u sub. So u equals x squared plus 4, and du is equal to 2x dx divide by 2. This one is an arctan, right? So we're kind of ready to go now. So this is again why you guys have to know arctan right when you see it. You just got to know it. ln of the absolute value of x plus 1/2 integral of, what would this be? 1 over u du. That cancels with that. Let me just make sure. Yes. Yep. 1 over u du minus, oops, minus tan inverse. Oops, I think there's a little bit extra to this. Remember the formula for arctan had a, it was 1 over a, but in this case, a is 2, right? Because this is x squared plus 2 squared. So this would be 1 over 2 tan inverse of x over a, so x over 2 plus c. Now, last little bit of cleanup. Ln of absolute value of x plus 1/2 natural log of x squared plus 4. And again, I probably don't need the absolute values on there, but I'm going to leave them for now. Minus 1/2 tan inverse of x over 2 plus c. And this would be my correct answer. I would take this, okay? But I have a feeling, once again, the book is going to say that you have to do the ln of the absolute value of, oops. So since these are addition, it's going to be the absolute value of x times x squared plus 4 to the 1/2 power. Remember, I just moved that power up to the argument. Minus 1/2 tan inverse x over 2 plus c. This would be the answer I think you'll see in the book, but I would take the green answer as well. Okay, so that would be one of the hardest ones. And again, I hope you guys see why this one is considered a harder problem. In the meeting, if you guys want to go over another one of these, I think I have another one we can do. And I'm not going to do case 4. Case 4 you might have learned in pre-calc, but that's for repeated quadratic irreducible. So I would do basically the same problem, but instead of x squared plus 4, it would be x squared plus 4 quantity squared, or quantity cubed. And it's the same thing as case 2, but just way harder. So we're going to stick to 3 cases. And then from there, you know, we can do that. Yeah, I don't see another one I want to do in my notes. That should definitely be a good start for you guys. Oh, geez, I kind of see one that, that's a much harder one. I might have to make another video for this one. But that'll do it for this, guys. I got to cut this video a little bit short, and I'll add some problems maybe to the next review video. Okay, you guys, thanks for watching. I'll see you in the next class.